All right. Factoring. This section is kind of short, but it's also kind of important, you know. We have a polynomial expression up here. That's what we call it. Polynomials, poly meaning many, nomial meaning name. So it's really, name means term here. So we have a many term thing with 3 terms. We call it a trinomial, okay? The power or the degree of a polynomial, whether it's a function or an expression, is the largest exponent on the variable term. So that would be 3, right? So we call this a cubic polynomial or a degree 3 polynomial. That term that has the largest degree, we call the leading term. That's its name, the leading term. Is x cubed written in the front? No, the leading term is not always written in the front. That's not what makes it the leading term. Some leaders lead from the rear, right? That's what this guy's doing. The leading coefficient, we call the numbers in front of the variables, we call those coefficients. The leading coefficient is 1, okay? So the leading term is 1x cubed, the leading coefficient is 1, the degree of the polynomial is 3. We have 2 other terms here. The squared term we call the quadratic term, because the graph of x squared is a parabola, so it's a quadratic term. And we call the x to the first term the linear term. Fantastic. See, you have had this before. And it's because when you make a 1 up there, 1 is in the shape of a line. That's why we call it the linear term. I think. I just made that up. They never taught me that in math school. No, but that'll help you remember it, right? The 1 is a line. We call it linear because the graph of 28x graphs as a slanted line. Or in this case, negative 28x would be a negatively sloped slanted line. And then there's another term that could have been here called the constant. It's really the 0th degree term. All right, the constant would be just the number plus the number. It's not there. All right, so the first thing you want to do when you are faced with a polynomial expression like this and you have to factor it, just for systematic procedure, you want to write it in descending order of degree because that's what you're used to. So the associative property of addition allows us to do that. So that'll be a 1x cubed plus 3x squared minus 28x, okay? That's just housekeeping stuff. Maybe in the past, they've always been given to you like that, but that's kind of boring, right? So I like to jumble the terms up a little bit. All right, now, once you have it in descending order, the first rule of factoring is not to Google it or ask your friend or to panic or any of that. The first rule of factoring is simply to look for a common factor. That's what you always do first because it can make everything else, the rest of the factoring process, easier. So when you're looking for a number common factor, you're looking for something other than positive 1, okay? If there had been a number in front of the x cubed, in other words, if the leading term had been some, or leading coefficient had been something other than 1, you would look to see maybe if you can factor that number out of each of the 3 terms, because as the conversation was over there, when the leading term is 1, x to the whatever, it's a lot easier to factor. When it's not, it's more fun, okay? We don't really have a common factor in here other than 1, so there's no number to factor out. But I will tell you this, and this shows up in example 1 on your notes. If you ever have a negative leading coefficient, whether it's just negative 1 or negative 2, you always want to factor that negative out, which will change all the signs behind it. Reason being is it makes the rest of the factoring a lot easier to do, okay? Y'all never really learned to factor with a negative leading coefficient. So if the leading term is a negative number, you factor it out. Okay, so that's a moot point here. Now you look for variables. Do we have any variables that are common? And in here we do, right? They each have at least an x. All right. Factoring out, which again is going backwards. It's the inverse operation of expanding or foiling, right? Which is always a little bit harder. Factoring out is the same as dividing out. Just like distributing is multiplying, right? When you distribute or FOIL, you're multiplying. So this is dividing. Now, I want to show you this just one time. It's like going through and dividing everything through by x. Now, that's not legal. Don't do that in the flow of the problem because if you just go through and divide each term by x, you're changing the value of that expression. And remember, we can't do that. But I'm doing this just to illustrate. When you factor out an x, it's like dividing out an x from each term. X cubed divided by x is x squared. 3x squared divided by x is 3x. Negative 28x divided by x is negative 28. Okay, so that's what we do. But where did the x go? If it were an equation, we could do it to both sides, and that's okay, kind of, not really in this case, but do your math homework, right? I'm going to delete that. When you divide out, because we still need it to be equivalent, we put that factor that we divided out front. Okay, so it's still there, right? And at any time, if you're unsure if you're factoring correctly, just redistribute and see if it gives you the same answer as the line above, right? X cubed plus 3x squared minus 28x. I'm awesome. Boom, right? Well, the game's not over yet, okay? Because now you're faced with this piece here, which is maybe what you're more akin to, right? We call this a quadratic trinomial with a leading coefficient of 1. These are the easy types, okay? Here's how you factor it. This could possibly factor into the product of two linear binomials. You will always see me do this. I always put parentheses down first, just like when I have a fraction, I build the shelf first. It's a lot easier to put things on a shelf when the shelf is there. It's a lot easier to factor, which again, a lot of the times is just guess and check. It's a lot easier to guess and check when you already have the receptacles there, okay? Now, because this is x squared, when you do FOIL, that's going to be the first that you get. So that should be x and x, right? If you do the first part of FOIL, look, first x times x is x squared. That's easy, right? The last, the O and the I you have to check, but the last is this product right here. This is the last, and that's how we get negative 28. So you might have learned target product, target sum. I'm not sure. The negative 28, the constant is your target product, right, for the last. And then the 3 is your target sum of the inner and outer. So what you're looking for here is factors of negative 28 that add up to 3. This is your target product. This is your target sum, okay? And sometimes it's a guess and check. What are the factors of negative 28? Well, negative 28 and 1. When you add those together, you get negative 27. That's not 3. That's not going to work. What about 28 and negative 1, huh? Well, that gives you positive 27. That don't work. What are some other factors of 28? Oh, 2 and 14, right? Or 2 and negative 14. But that gives you negative 12 or positive 12. We're getting closer, right? After a while, or maybe immediately, you know what the factors are. What are they in this case? 7 and 4. But what type of 7 and 4? Well, good. It's got to be a positive 7 and a negative 4 because, let me multiply these. Positive 7 times negative 4 is negative 28, and positive 7 minus 4 is positive 3. So that means you're going to have a plus 7 and a minus 4 right there. And when you're doing guess and check, you might have multiple different ways to factor the last or the first and the last. When I grew up in the Rio Grande Valley, math was big down there, but we didn't have fancy snowflakes and never snowed in the valley. We had to factor by brute force guess and check with no air conditioning, with fruit flies from the orchards in your face, dripping onto the paper sweat, and you had to like focus, all right, you know. So it was a good experience. And then you get beat up at recess, right? All right, it was tough. So let's check the inner and outer, right? Inner is 7x, outer is negative 4x. What's 7x minus 4x? Positive 3x, kaboom. Now, how do we know when we're done? When we get tired or we get stuck? When you have only factors that are, we call all of these factors, we call these prime linear factors. There you go. Y'all kind of know when to stop, but here's kind of stating it. A prime linear factor does not factor anymore. They're linear because I wrote them in a straight line, yeah? They're linear because they're all of the form mx plus b, okay? That's one way to know you're done. The x, don't forget x. He doesn't have the fancy parentheses that the other dudes have, but it could, right? X plus 0 or x minus 0 if you want to fancy them up. So that's 1x plus 0. That's mx plus b. Here's 1x plus 7, 1x minus 4. If you can get it down to linear factors, you're done. But in this class, we'll look at another type of factors. Okay, you might have this, or what I call irreducible prime quadratic factors. Okay, here's an example of that. X squared. Hello. I mean, this is like, I was going to say, it's kind of like amazing how I can just sit here with this device and it just magically appears on the board without wires. It's pretty amazing with wires. Like, how does it get through the wires, right? But without wires, it's like even more amazing. You know, it's like floating through the air. All right. Man, I thought today was going to be a good day. It's kind of a creepy photo, right? You're like, where's that lady coming from? She's not back there, right? Like, what is that? Is that a ghost? There's like some Victorian ghost. Anna Boleyn, the King Henry VIII's wife, is like haunting room 903. She did, yeah. Poor Anne lost her head. And it wasn't from doing math. Come on, come on. Anyway, what I was going to tell you is an irreducible prime factor would be of the form x squared plus b, like x squared plus 25. X squared plus 25 does not factor anymore. It's done, okay? It's a sum of two squares. It's an irreducible prime factor. However, if it were x squared minus 25, we would be able to factor it. All right, and we're back. So here's what I wrote down. Prime linear factors of the form mx plus b, that's how you know when to stop. Or irreducible prime factors like x squared plus 25. We call that a sum of two squares. But look at this. If it were x squared minus 25, that one does factor. So there's no common factors there other than one, and it's not a trinomial, but this one does factor. It is a difference, right, of two perfect squares, right? And we call that a special product, right? Like Kaboom is a special product for the bathroom. It dissolves soap, scum, and lime deposits. Do your math homework. X squared minus 25 is a special product in the math class. It factors in to the product of two, what conjugates? Do you remember? Conjugates. Good. I'm pretty good at giving clues. The square root of x squared is x. The square root of 25 is 5. One of them's plus and one of them's minus. We call those conjugates because the only difference is the sign between the two terms. So a difference of two squares can factor. A sum of two squares cannot. It's already prime. Got it? So factoring is very important, but it's also kind of difficult, as I mentioned, you know, because going backwards typically is. In fact, the entire internet security, web security, e-commerce, when you buy something on Amazon to send Jeff Bezos to space, your transaction is secure because of factoring is hard, believe it or not. Public key cryptography, which is the mathematics behind keeping your information safe, works because factoring is hard. Okay, if you want to look into that, you can. Now, I do want to say one last thing about our answer up here. Some students are trained to a certain degree, right? A little knowledge is a dangerous thing. They want to get to this factorization that we had right here, and then they'll go straight to this. X equals 0, x equals -7, and x equals 4. Okay? You might have been wondering why I didn't do that. Why didn't you finish the problem, right? I did. I had a mathematical expression. There was no equal signs in there at all. If you start throwing in equal signs, I'm like, where did that come from? Why are you doing that? Okay? But there's a reason why you probably are thinking that. Here's why. Factoring is important to us not just to keep our transactions safe, but because it helps us solve equations, right? So if we were to have an equation that we were trying to solve, and we got everything on one side and we set it equal to 0 and only 0, now we have what's called a conditional equation. And if we can get it equal to 0 and have it completely factored on the other side, now we can set each factor equal to 0. And it works because it's called the zero product property. Anything multiplied equaling 0 can only be 0 if at least one of the factors is 0. That only works with 0. It doesn't work with 5. Two things can multiply to give you 5, and neither one of them has to be 5. Right? Like 5 halves and 2. That equals 5 when you multiply them. But with 0, that's not the case. At least one of them's got to be 0. So that's where you can then set each factor equal to 0. Either x equals 0 and solve, x plus 7 equals 0 and solve, x minus 4 equals 0 and solve. So that is part of this section. But we're not going to focus on the solving of the equations today. I want you just to be able to factor today, okay? So here's what I want you to do. I'm going to give you the rest of the period to work on example 1, all right? Example 1 has a whole bunch of, well, there's 9 of them, really. It should, some people last period finished. I was pretty proud of them. But they get a little more interesting as you get down towards the bottom line. If you can't get your leading coefficient to be a 1 in a trinomial, there are several ways to factor it. Guess and check, split the middle term, snowflake. I heard like crisscross method before, which is variation on snowflake. I've heard of the castle method before. So there's lots of methods. I don't want to like explicitly teach you all that today because I want to see if you can figure it out. And again, don't be afraid to put your factoring parentheses there and do trial and error. 3x plus 2, 4x minus 5, and just do FOIL and see if it works. Because if you do trial and error and it doesn't work, you can figure out why it doesn't work, and then you go back and fix it and try again. So there's a lot of trial and error in factoring. It's not like multiplying where you have a recipe, right? FOIL, or was it saran wrap? I forgot. That's why I don't like FOIL, because it doesn't always work. Okay, don't put it in the microwave either. All right? So you have the rest of the period to do this. You can work together or by yourself or alone. Those are the only 3 things, okay? If you have a question, seek out that math buddy, right? Math buddy, math buddy. And at the very least, you Google it. If Khan can't teach you and you ask me, I will reluctantly but happily maybe grunt in the right direction. Today I want to see what you folks can come up with, because you've had it before. It's in the recesses of your brain and we just need to get it out, okay? And then tomorrow we're going to go over this. We're going to go every single one of these tomorrow, and that might be really all we do for this section, okay? So maybe not even do the worksheet, or maybe I'll just say do the problems, you know, 1 or 2 on the worksheet, okay? And then we're going to move on to the next section. So we're going to kind of fly through this in 2 days, okay? On your marks, get sets, go if you haven't already.